welcome back everyone to Maki Academy Learning. Today we are not going to attempt to solve any question. I just would like to continue to the subject of stress transformation. After we learn the stress transformation in this video, I'm going to introduce to you the stress transformation and related equations to the plane stress and plane strain concept. Right, so stress and strain, they are both interchangeable with a set of rule, right? For example, on the top right here, I'm showing the relation between plane stress and plane strain. They are governed by Hooke's law, right? They can go to plane stress can be changed to plane strain. Normal stress and shear stress can be changed into the small Greek letter at the bottom right here, epsilon and gamma, is representing the normal strains and shear strain. Like we have for sigma for normal stress and shear for the tau, represented by the letter tau, right? So they can be changed from a plane stress to plane strain, which I'm going to explain in this video the concept of the two. If we can use Mohr circle to describe the major and minor stresses for the system, we also can use, but this time around we can use Mohr circle of strain to find the major and minor strains for our system. So the significance of learning strain transformation is what you have right here, the strain rosette, right? The strain rosette is what engineers are using to measure or to calculate or to specify the strength of one material. I would like to introduce to you from the left right here. This is the 0-degree angle strain rosette. The strain rosette consists of the base and the grid. So the grid length is predefined. So we can say that is also the gauge length for the strain rosette. The strain rosette is also known as a load cell. So load cell is the thing that you have in your universal testing machine, right? I would like to probably illustrate right here. If you have a sample that you want to right? You want to test. So you need to, in order to know the strength, right? The Young's modulus, the Poisson's ratio, the yield stress for the material, right? It can be tested. Uh, uh, it can be measured by the machine. So this machine is sitting. This is universal testing machine that usually we have in mechanical lab, right? So this is the machine, can be illustrated like that. So this is the force given by the machine. I call this universal testing machine. This is where load cells or strain gauge located. It is basically a sensor to feel how much force given, can feel the force given to the system. And again, to in this test, I'm illustrating the compressive stress on the sample. So say this is the sample that we have for your test. So next, this sensor need to be read by this DAQ. So engineers call this um, data acquisition system. So last but not least, probably you're going to have a computer or visual. This is, I'm going to call it PC. So this system from the load cell for the machine, going to go through uh, DAQ, data acquisition system. So from this reading, this is DAQ system is where you calibrate, right? Every time you install the load cell, it need to be calibrated. Otherwise, the reading going to go off. So last but not least, it's going to go to PC and read your data as perhaps in this case force and displacement, right? So Newton and millimeter. So this is how engineers are measuring the strength of the material. So you can have the strain gauge as or the strain rosette or the load cell. There is a whole field of mechanical testing. So engineers going to utilize the load cell or strain gauge in order to measure the strength of the material that they wanted to know. So like example over here, um, force is given in terms of Newton. So you can pull this steel rod. So you can call this steel rod. So in order to know the strength, the Young's modulus, the how much this load cell going to extend in terms of displacement, right? So this is the gauge length of the load cell. So I've shown on the picture right here. This is 0 degree. You have some types of string load cells also with 0 degree, 45 degree, and uh, 90 90 degree load cell. So it could be any arrangement, right? Universal testing machine that is typically they are using the load cell. Um, there are many load cells installed in this sensor right here, so it is very sensitive. So be careful when you are handling the machine. So you don't want to go beyond. If the load cell is described for 50 kilonewton, you need to prepare your sample so that it doesn't exceed this value of 50 kilonewton. There are more uh, sensitive sensors of 1 kilonewton load cell, because the load cell consists of, it looks like this is a mechanical device, but it works on the base of voltage, current, and resistance of the current given to this device, to the sensor right here. So uh, of course the combination of electrical knowledge right here, so to give to the gauge length by using these copper wires, all right? So by using the suitable arrangement, it can compute the distance. The distance is what you need from the uh, force displacement graph, right? So whenever you give the force in terms of Newton, so that is how much um, the displacement going to be uh, received by your sample. So it is a mechanical device to test your sample to know the properties of the material. So strain rosette is important. That is why a strain transformation is important to understand, to know each and every related equations to this concept of strain transformation. So to end this introduction for strain transformation, where uh, we talk about plane stress and plane strain, the purpose of understanding is to get into uh, the device that you are seeing right here. So the next you are not going to see it. Of course the strain rosette going to be mentioned in the question, but most of the time it will be given as a schematic diagram from there. And before I forget, the length and the readings that you're going to be seeing from your strain and your shear strain is in microns. Microns is 10 to the power of -6. So micrometer, right? Micrometer. So the symbol also micrometer, or simply we call this microns. So I think that is all for this introduction. And please, if you like the video, share it and subscribe, and to see more videos coming to your feed. Thank you very much, and goodbye.